Assignment statement. It's a bit weird. Let's just call it assignment then. Alright, let's just check the document. What does the document say? Assignment's supposed to be here. Assignment statement. Target expression. Target is identifier. Right, let's just follow whatever you do. What the heck is that? Identifier. Expression. Target. Currently, we don't really have much else to do with a target right now. Is the co-pilot off? Why are you doing stupid things? So 语法这样是没有问题的。Value assigned, determinant, identify value, assign value plus one terminator. Yep. So my process is from character. Oh, I see. What's wrong with me? I need to drink some water. Simon 就是需要把它的 type 检查一下，两边是一致的就行了。Equals. Do we have a type check here? Yes, we do. Oh, okay. Operate the list of type. Should I make a new one? I don't think so. It should be okay. Just try to make you happy. I don't want to create a new one. How can I combine them as a, a array list? List of what? List of type. It doesn't matter. Why do you want to give this assignment itself integer type? You're not gonna continue assign to the left, so you don't need to do this. It's like, why bother? Oh, unless you want to pass the type all the way up. No, because the assignment up there is no one really cares. So you don't need to do that. And which means if it's not, then you do this. Otherwise, you don't need to do anything. Yep. So let's say, what if they're different? No, it's gonna complain in the operator, so forget about it. All right. If we know one is not writable, who's gonna comply? Of course, semantic check the type, so we should know. So we actually need to check that this is not okay. But before we do that, let's just go on and finish the code generating. Just assume that it's possible to assign a value to the place. So, which means for the ASM code generator, we should probably add a visitor to this place. Leave, right? Gotta do something here because it's a void code. It should be void, and remove the left and the right. Append the right in the opcode for store. Node type. That's the address. That's a value. Opcode for store. Where's the opcode for store? Oh, here. Opcode for store. Interesting. Who wrote this code? Is it me? I don't feel so. Who knows? It could not be me. It doesn't matter. Semantic compile. I would say, hey, I don't know this type. Because no type, someone has no type. Yeah. All right, good. Assignment node. We got node. Oh, node type. No, it's not node type. But why do you want to get a node type instead? Interesting. It returns 43, which is okay. Actually, no, it's not, because this is immutable. You're not supposed to change it. So, assignment IMF. And let's make it easy. 0 and reassign to 1. And you don't need to print it out. You should just report error immediately. Okay, it's not reporting error. And instead, well, it just returns, so nothing happens. Now we're going to make it really report, and it's semantic. So, semantic. Yes. So we're going to make sure that it's writable. Get type. Identifier. And it's this assignment, so we don't need to go any further. Identifier is mutable. Right. If it's mutable, what do you do? If it's mutable, then you should, this is semantic, right? So you should set the error type to the node. Oh yeah, maybe that's a good idea to set a node. Or just report error. We can just report error. Yeah, let's see. If it's not mutable, then report error. And by doing this, we could just return, because there's no need to go on. Is he mutable? That's mutable. Now, why are you generating stupid code? Declaration scope. Why are you using this? What the heck is this? Declaration scope? Oh, okay. I'm not going to touch you then. But mutable. It's not mutable. How likely we're going to change the mutable? Nah. We should actually tell when we create the binding. Hey, is mutable a binding issue? No, it's not. Binding are actually associated to. No, wait a minute. It could be. So you create a binding. But what if you override, you say cast this to a mutable thing and you override that? That's scary, but do we allow that? If we don't allow that, then the binding itself just means the binding itself is the type, the memory location of some identifier. So they could possibly be two different bindings, and they all have their own mutability. If that's the case, then when we create a binding, say who's going to create the binding? Identifying node. What the? No. What am I doing? Why I come here in the first place? Something wrong. Why it's ID? No, it's not you. It's the binding. Will we associate the identifier with different binding? Right now we're doing assignment. And while doing this, the binding should be created already. Because it's not declaration. Binding should be created in a declaration. So we can actually check if it's mutable. I don't need to go further. I just ask identifier, are you mutable? Unless it's a L value expression. If it's L value expression, that would be tricky, because the expression itself will be able to tell me the mutability. Like it's going to return some kind of binding. That's a totally different monster. Let's just do this for now. Okay? And to tell whether it is mutable, we will get the binding. But the binding might be created as null, so you might not have a binding. So when people query the mutability, I should assume this is not null and then return the binding mutability, and when I go here, I'll just return mutable is mutable. And let's create a view. It's here. And it's supposed to be is mutable. And let's just give it false. Can we do that? I can't do that? I can't? Can I do it this way? I don't understand. Show me the problems here. Why can't I? I don't know. That's very weird. So everything is not mutable. Now we compile, it will complain cannot assign to the mutable as error, which is good. So when we do pausing, it's fine. But the moment we do semantic, it will complain. Because we try to do the assignment. Okay. And now if I do apply test, it will fail. Well, yeah, it should pass because yeah, actually it passed. So because we expect it to be error, which is good. Now we can start with the correct one, which is a good one. Assignment mutable is mtu. So if it's mutable, then we should be able to see something. Where are you? What? Why? Why am I here? Where's my assignment? Oh, here. Nice. So here, for this one, we should be able to see 1. And if I run it, it should fail. Yep. And it failed because they say syntax here, expect for assignment. But shouldn't this be some token issue? Right? How do you know? It just ignored it? Yeah, I just ignored the token. Jesus, that doesn't feel right. Oh, not you. Oh, damn, let me close all. Where's my MTU? Yeah, here. It doesn't know MTU, so we treat it as an identifier, which is not right. And we need to update the lexicon analyzer for the keyword, because it is a keyword. So now we add a new keyword. Let's just put it under this MTU. Okay. So if this token should be understood. And now this MTU should be handled by the parsing, but right now it doesn't, because it doesn't know how to deal with this. So we need to update the parsing logic, and it's part of the declaration. So for the declaration, let's just go parse declaration. We'll see, hey, is it or no, this token, this or this. And for parsing, declaration read ID and declaration token is put here. So at least here we actually know this ID is a mutable one, but we're not creating binding yet. When we create a binding, we should know that it's mutable. Oh my god, there is a problem. My bad. How do we know that it's mutable? We actually rely on the parser to get the information. So when we create this guy, we don't have binding yet, but we already know that it's mutable. That is something. We haven't checked, we haven't created a binding yet. How do we know? Declaration. Should we put that information in this declaration node, or should we put it in the identifier node? It could be either way, but which one is better, cleaner? Let's think about this. When we built up the AST, it's all about the structure. And when we check the type, and the semantic information. We create a binding there. And for that binding, we know it's a mutable one. And who knows about this? Mutable or not is an attribute of the identifier. No matter where you move the identifier, it will follow it. So eventually it will be part of the identifier. But when we query identifier, mutable, the binding itself is the memory. It's the memory. the memory eventually represented by the binding, and the binding just associate some ID with the memory and other meta information. It could hold the mutability information there. Is it possibility that the same binding will be shared? Can't do that, right? Because that would be very weird if you do so. So the binding should be related to the ID directly. So you can query either one. So why would I? Oh, binding. I know. Because when you try to access some variable, you don't really know anything about it. You have to go to query to look for the binding, not look for the ID, because you don't really have the identifier node anymore. Even if you got it, you're just trying to get the string and query for the binding. So you query for the binding represents everything. So eventually we'll go with the binding. But now you have this thing before you create the binding, because you don't have types, so you don't have binding, but you already know that's mutable or not. So this declaration should kind of know it is mutable or not. And we get that information, parsing it out, and forward the token. We forward the token to the declaration node. Yes, we did. We put it into the declaration node. And declaration node has that token. So he has that token. And this declaration node is supposed to set the binding for the other guy, which will be the semantic analysis for the declaration. No. Why am I here? Declaration. So we got here declaration node. We'll actually add the binding. And when it add the binding, it will create the binding. Scope create a binding and set the binding. So all the way down here, it doesn't really know anything. It is this guy. So when we do the declaration over here, we know the binding. Identifier set mutable. Node get declaration type. No. It's supposed to be something else, like get token. Is So if it is a keyword of mute, then we set the mutability for this guy. And do we have this? No, we don't. So now let's create this. And when we set the mutability, do we know anything about the binding? No, we don't. And because of that, and because of this, everything defaults to not mutable. And if you want to set it, you set it later. And you want to get it here. So the ID has the information. Identifier node has information about the mutability. So when we do the parsing, we don't care. We just get that information. We go forward, and this token is saved here. So the mutability information is saved in the declaration node. And we do the semantic visitor. We have the declaration node, and we pull that out and see whether it's mutable. If it's mutable, we set it to the ID. Okay, and then when we do the binding, scope create binding, it will have a type information. If we don't want to change that interface, we could probably set the mutability later for the binding. But do we change the binding? I hope we don't change the binding, because yeah, that would be scary. I don't want to do that. But instead, let's create a binding, which allocate new binding. Allocate new binding, we do the binding. Who eventually do the binding is this. And allocate new binding. Know the type, location is mutable. Is mutable. I kind of want to know this information while we're doing this. So we try to get an analog binding here, create a binding. We should be able to tell whether it's mutable. And how can we tell? Well, we have the ID. So the identifier node should tell us whether it's mutable. And the bindings created here. Any problem? No. All right. So let's see. pytest-vv.x logs cannot assign to mutable, immutable, variable. Which one? Mute. We said mute, right? So how come you complain it's immutable? Dot 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 dot. And the binding. Try to add the binding. Node get token at binding. I rely on this one to do the work, but if it's not, then you should be able to tell us. So it's supposed to set true. Did it? It's mutable. And later we're going to query you, hopefully. And binding. So the ID is mutable, it's true. Getting scope. Next. Create a binding. Go ahead. Token ID. Get lex. Binding, allocate new binding. Let's get in. Oh no. Let's just go here. Is mutable true. So we got here is mutable true. New binding. So we should be able to come here and see mutable is set here. Okay, let's go. Yeah, it's set to true. And when we do the assignment, it will be an semantic analysis for the assignment, which is here. Go on. Okay, we get the ID. Oh. Nah, that is wrong. We got the ID, but this ID is a different ID node. This one doesn't really know anything. We need to query we need to find the binding. Yeah, that's right. Because this ID is totally different. We didn't really touch anything about the mutability about this one. We need to query the correct thing. How to get the binding for an ID? Well, assignment. We didn't do assignment, do we? Even if we don't do assignment, we do operation, right? So there will be some kind of like an operator node. And left get type, right get type. Oh, they only get the value. So how would I be able to tell the assignment? Oh my gosh, I can't really get the binding. So if we visit this identify node, it's been declared as being declared. Find variable binding and set type, set binding. And also set mutability. It's mutable. That's how we can get the information back. I wish you can reuse the session instead of creating lots of same ideas. Alright, test. Okay, all pass. So now we have now we can change values. This is pretty cool. What can we do about it? Oh. Some kind of like a global variable mutation, yeah. But the language right now doesn't really have the global variable declaration. I wish I could add it, but let me do that when I finish all the tests for this like course, and then I can extend it, the feature after. So right now we have to mute this one to mutate the value, which is actually pretty good. Let's add more. Let's see. Assignment. This is using assignment, kind of like a BA test. Let me just pick a value and oh no, we don't allow them to change the parameter directly because parameter is as default declared as immutable. Right, it is not mutable. I can't change it. So let's say let's just like you can print v with no problem. That's fine. What the? What? I don't think you can. Right, you can just print it, and also you can create a new value based on it. But the moment you try to get it a new value, it's gonna complain. Right, so v is immutable unless for the semantic. Yeah, semantic. Semantic for the parameter. Do we have oh, that should be the first pass for parameter. For parameter, what do? We set to the type. Oh, only set the type. Parameter node. How about this one? Semantic create a binding. See, we create a binding here. Add to the binding, semantic binding. If we actually make the binding here as a mutable, so it could do identifier dot set mutability equals to true. Then this is how you can allow people to change the parameter if they want. And if that's the case, you could probably just compile this guy. Wait, still immutable? Wait, didn't I change it to mutable already? This one is not. Create a binding, semantic add-in binding, create a binding, semantic parameter node, accept. So this is a parameter node, parameter accept. And the program here is right now as parameter. Okay, let's rerun it. So what is the identifier right now? That's F. I don't care. Wait, F? F? F supposed to be not mutable, right? It will be. Oh, okay. I'm on the right side. This is for the. Darn it, this is for the function, not for the arguments. Stupid me. I'm on the wrong place. So who is doing the parameter? Who is doing the parameter? Set binding. Oh, you. Parameter node. Set mutate. So by doing that, if I do compile, and let's just disable everything, I'll let you go. That will work. And let's compile and run. What is the problem? See, get the exception not found first pass. Oh, wrong file. Should here. Sorry. Compile and run this program. We should be able to see one. Yeah, that's how you can make the arguments purely local, and you can modify them. So I don't know which one they like, but just for this exercise, let's just look at this exercise, because we only care about right now the exercise itself. Mommy. Oh, still one parameter. It would be 3, right? Scoping here. The only definition appear in the parameter scope or the parameter of the function, which will be treated as if they were declared immutable. On the other hand, definition can appear in the body, for example. So it's immutable. All right, cool. But that's just one line change. We should be able to handle that very easily. This one we don't want. This one we don't want. Let's just delete them. And it should be fine, no matter whether it's mutable or not. But since we don't want it to be mutable, we can close that feature. Because for me, I kind of like it mutable, so. Well, there might be a reason why it's not mutable, because no, it doesn't make any sense to be immutable. Even if the arguments used to be constant, the moment you pass it in, it's a copy of it. So I don't see a point to keep it immutable. All right, let's see what changes we made. What? So that's a mutability. We get the mutability from the ID, and then default 2. Not mutable. And we add the assignment support. Oh, the whole, yeah, whole task is trying to add the assignment support. That's straightforward. It's mutable. That's false. Is it mutable? Return this. Set mutable. Pause logic. Assignment. Declaration. Yeah. Looks good to me. How to clean it up? I never, ever understand. Merge what? What is that? I got terrible memory. Assignment something? Yeah, assignment. Holy shoot. Okay. Oh, just the one change? refactor. I don't really think that I need to do refactor anymore. Right. Yeah, that's okay. This should be it. Did I push? Yep. All right. That's it.